Hi everybody, welcome to section 9.3a, transfer. We'll spend 2 days on transformations, but first let's talk about what transformations are and how they affect a parabola and the graph on the coordinate plane. So first of all, a transformation changes the size or position of a figure. There's 3 kinds of transformations we're going to talk about. The first one is a translation. So a translation moves the figure up, down, left, or right. So you can see from the graph, I've got this blue parabola with its origin, the origin as its vertex. And notice how I translated that figure up or down. So that's vertical, right? Up or down is vertical translation. And what that looks like in our equation is we've got an x squared and we add some number at the end. If that some number is greater than 0, we end up translating up. I'm going to put shifts up or moves up if you prefer. If your k value, your number added at the end, is less than 0, so like say -1 or -1, that parabola shifts down. Horizontal translations are when we move left and right. These ones you have to be really careful. Watch the sign carefully on these. So these are left and right. So notice, first of all, in the equation, I've got f of x equals x minus h. We used a k at the end on the other one. Minus h in parentheses with the squared on the outside. So here's an interesting thing. Notice how on my graph I've got the blue parabola again with its origin, the origin as the vertex, and then I've got my green and my red graph on this example that move back and forth, left and right. Notice it says when h is greater than 0, makes sense, right? The parabola shifts right. However, be careful because the sign inside that parenthesis is a minus. So you have to watch. If it was like, let's do a little example right here. I might have a y equals x minus 3 squared. That 3, I leave the minus behind, shifts that parabola to the right 3 places, or positive 3 places. If my h value is less than 0, my parabola shifts left. And an example for this one might be y equals x plus 3 quantity squared. Well, my h value here, I leave the negative behind, so the only way to take that out is to use the opposite sign. Like that would be like x minus a -3. So that shifts to the left. You have to really watch that sign thing for horizontal translations. Be careful on that. A dilation is the second type of transformation. Dilation, I always think of a copy machine, how you can reduce or enlarge things. Well, it kind of works the same way. A dilation makes the graph narrower or wider than the parent graph. Narrower or wider. So again, on my examples, the blue one is always the parent graph. So this one right here is y equals x squared. Notice, and I didn't color code these very well, if I just take the value of a, so a, here's my equation. If I've got a number out in front of my x squared, remember that's always a. If that number, absolute value of that number is greater than 1, so the sign, positive or negative, tells us if it opens up or down, but the actual number, like 1/2 or 6 or 3 or 2.75, tells us about how narrow or wide that graph is. So if the absolute value, just the number part, is greater than 1, that means that my parabola stretches vertically. In other words, if that doesn't make sense to you, stretches vertically. It makes it, nope, wrong one. It makes it narrower. That one's going to go down there. If my a value is in between 0 and 1, and remember, I'm not talking about the sign, I'm only talking about the number. So we're talking about a fraction probably, or a decimal, 0.5 or 1/3 or something like that. If it's between 0 and 1, my graph compresses vertically. That makes it wider than the parent graph. Compresses, think about if you sit on it, it will compress, it will get wider. If you stretch it vertically, up and down, it's going to get narrower than the parent graph. Reflection is our third type of transformation. A reflection, everybody knows this one. A reflection is just a mirror image, or your figure gets flipped across a line. We're really only going to worry about a reflection over the x-axis. So kind of a strange way, notice my equations are in my box this time. So if my f of x equals x squared, that means my a value is positive, and we know the graph opens up. We also know that our vertex will be a minimum. We've got all kinds of other things we've talked about. If my equation is a negative x squared, that means, of course, my a value is negative. We can mix and match the reflection with the dilation, so we could have like a -1/2. We can do things like that. My a value is negative, which we all know means that our graph opens down. And then we also know other things like, well, if it opens down, that means my vertex is a maximum. So it's the red one on the graph where it's a negative. I don't worry so much about this equation right here, negative y value or negative f of x. That just does a mirror image across the y-axis, which it's already a mirror image. So it doesn't do a whole lot. So this one is really the important thing that I think I need to say. When a is a negative value, this is a reflection over the x-axis. So we just flip it over the x-axis, we have that mirror image. All right, so let's talk about a couple examples here. Let's do a couple. Describe how the graph of each function is related to the graph of f of x equals x squared. Remember, f of x equals x squared is our parent graph. So how does that compare? So for the first one, g of x equals -2x squared minus 3. Don't get all caught up on this g of x and h of x. It's another way to say y. It's saying it's another function besides f of x. We called f of x equals x squared, so that's our parent graph. So that's why we're not reusing f of x. So first of all, what does this negative tell you out in front for your a value? That opens down, right? Opens down, or our vertex is our max, if you like. What does the 2 tell you for the a value? Remember, if we just take the number, the absolute value of a, we don't care if it's a positive or negative. The 2, that is greater than 1, so our a value is greater than 1, means it stretches vertically. Or you could say it's narrower than the parent graph, if we graphed both our original parent graph and the other one together. And the last thing I've got on here is this -3. What does a number added at the end or subtracted at the end tell you? That's going to be a shift. Will it be left and right or up or down? If it's in the parentheses, remember it's left or right. If it's out on the end, it's up or down. So this is going to shift down 3 because it's a -3. So you look at each piece and look and see what it tells you. Number 4, I've got a negative out in front. What's that negative out in front tell you? It opens down or it's reflected over the x. The only other thing I've got is this -4 inside the parentheses. So if it's a minus, I know that it's going to be a translation. Will it be left and right or up or down? It's a left or right, right? So what is that value? Which way is it going to translate? So it's going to shift which direction? Remember, it's like we just take the number, leave the minus behind. So that's going to shift it right 4. You need to figure out some way to help yourself remember that it's always leave the sign behind for that one piece. All right, I've got a multiple choice here. Go ahead and try to do that one. But what I want to know from you is, what is the one way that the graph of g of x equals 2x squared is different from the parent graph? There's only one way. I picked an easy one so that you only had to look at one thing. Remember, the parent graph is x squared. So what's the difference? Don't just tell me the number, but tell me what the number does. And your practice problem, on this particular graph that I put up here, identify the horizontal and vertical translations and the sign of the a value. So will the a be positive or negative? How far horizontally is it translated and how far vertically is it translated? Right, so answer those 3 questions plus the lesson summary. Have a great day. We'll see you next time.